Line up the decimal points by place value.
Watch the scene first. The math is built into the world, so the quantities can be seen before they are named. Here on Numberline Shore, exact physical measurements are marked along the stones and water, labeled with standard 6.NS.B.3. To calculate exactly how far the turtle travels, we add 5.62 to 3.8, combining identical place values. To solve the misalignment on the right, write 3.8 as 3.80, perfectly aligning the columns. Add the hundredths, tenths, and ones. The sum is 9.42. Using a placeholder 0 is a structural necessity. It guarantees we are combining physical quantities of the exact same size. Moving down to the water depth reads, let's find the difference between 8.5 and 2.73. Look closely at the top row. We have an empty space above the 3. We cannot subtract 3 hundredths from an empty void. To subtract hundredths, we explicitly reveal the hidden hundredths in our starting number by writing 8.5 as 8.50. Now subtract the hundredths, tenths, and ones in aligned columns. The difference is 5.77.
Regroup across place values when you subtract.
Filling empty spaces with zeros forces our notation to accurately reflect the true physical difference between two exact points on the shore. The turtle continues to a cluster of lily pads, bringing us to a new operation, 2.4 times 1.5. Multiplication requires a rule shift away from vertical alignment. Ignore the decimal points for a moment and compute the values as whole numbers. 24 times 15 is 360. Now, how many decimal places do the original factors have altogether? They have 2. Place the decimal point by moving 2 spaces from the right side of our whole number product. We get 3.60, or simply 3.6. Multiplying tenths by tenths naturally yields hundredths. Counting total decimal places is the way to scale these quantities correctly. Matching the animal's movement to the symbols on the shore reveals the structure of these operations. We align place values with zeros for addition and subtraction, and count total decimal places to scale our multiplication. The environment shows the relationship, and the notation records it. All 3 operations provide exact results when we apply the standard algorithm. Which mark in the environment proves the mathematical relationship, and how does the animal action make it true? Using these algorithms ensures our measurements stay consistent as we track each value along the numberline shore.
Count the decimal places in the product.